Hi everyone, in this video I'll be sketching a curve when f of x equals 2x squared over x squared plus 4. We will be asked to find the domain, intercepts, symmetry, asymptotes and behavior, intervals, local max min, concavity, and inflection points. I will first be calculating the asymptotes. First, right off the bat, you can see the equation is neither top-heavy nor bottom-heavy. It is a balanced equation. There is an equal degree of x in the numerator and in the denominator. You can easily find the horizontal asymptote by finding the ratio of coefficients in front of the largest degrees of x. You can divide 2 divided by 1, which equals 2, so then the horizontal asymptote is y equals 2. Next, I'm going to calculate the end behavior. The limit of f of x as x approaches infinity and the limit of f of x as x approaches negative infinity equal 2, because the horizontal asymptote directly correlates to end behavior. Next, I'm going to calculate the domain. Because there are no vertical asymptotes, the domain will just be negative infinity to positive infinity. The horizontal asymptote does not affect the domain. Next, I'm going to calculate the intercepts. I'm first going to plug in 0 for x to find the y value. After getting 0 for y, I'm going to plug in that same number into the equation to find the x value. The only intercept for this function will be 0, 0. Next, I'm going to calculate the symmetry. First, I'm going to copy down the original equation. And in order to find symmetry, I need to plug in negative x. For a function to be even, f of negative x has to equal f of x. For a function to be odd, f of negative x has to equal negative f of x. For an equation to be neither, it doesn't equal any of these. So after plugging f of negative x into the original equation, f of x, you can see that f of negative x equals f of x. So the function is even. Next, I'm going to calculate the intervals. I will first have to find the derivative of the function by using the quotient rule. So then the derivative is 16x over x squared plus 4, the quantity squared. I can then use this derivative to help me find the increasing and decreasing intervals. Negative infinity, 0 is the decreasing interval, and 0, infinity is the increasing interval. Next, I'm going to calculate the local max or min values. I will first set the derivative numerator equal to 0. I will then plug this value back into the original equation. So then 0, 0 is the local min. there is no local max. To find the concavity and inflection points, I will have to take the second derivative of the function.
A few moments later.
So then the second derivative is 64x times the quantity of x squared minus 8 over x squared plus 4, the quantity to the fourth power. I will next find the concavity of the function by using the intervals we calculated before. Because both intervals are concave down, there is no inflection point. Finally, with everything we have calculated, we can sketch the graph of the function.